Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 4.4, which is going to deal with perpendicular lines. Now, for today's lesson, we have one learning goal, and our learning goal is you will be able to define what perpendicular lines are and use the perpendicular bisector theorem properties to find side lengths and angle measures. So we're going to take a look at perpendicular lines, and then we're going to use the perpendicular bisector theorem to go through and find either angle measures or side lengths. All right, so for today, before we jump into our first example, let's talk about a few bits of terminology here. All right, first of all, recall that perpendicular lines are lines that cross at a right angle or 90 degrees. What that means is that XY and AB are perpendicular because they cross at 90 degrees, as indicated by the angle box, or the fact that it says 90 degrees. The symbol, and it looks like an upside down capital T, means that two figures are perpendicular. For example, L is perpendicular to M, or XY is perpendicular to AB. So anytime you see this upside down T, that represents that the two lines are perpendicular. So perpendicular lines cross at 90 degrees. Keep that in mind for when we get to the back of our notes, and specifically example 3. All right, perpendicular bisector theorem states, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what in the world does that mean? Well, what it means is that point X is the same distance from endpoint A as it is from endpoint B. So if we look at our point X here, what it states is that X is the same distance from A as it is from B. Meaning, and these might not be perfectly straight, but you'll get the idea. If I were to go through and draw two lines from A to X and then B to X, the measure of these two lines would be the same. So what that states is that if I know that these are perpendicular, if I know that this is 5, that means I know this is also 5. So we can use the perpendicular bisector theorem to help us figure it out, as long as we know that this segment is the same measure as that. If I know that these two segments are the same measure, then I know AX is the same measure as BX. So that if I knew AX was 5, I would know BX would also be 5. So X is the same distance from A as it is from B. And that's what this theorem states. So we're going to use that to really help us go through and answer our questions for example 1. All right. For example 1, part A, let me go ahead and move this up here. For example 1, part A, it says to use the perpendicular bisector theorem to answer the questions. Now for part A, it says use the diagram shown. BD is the perpendicular bisector of AC. So this crosses at 90 degrees with this line, and it cuts this in half, so I know AE is the same measure as EC. Now for the first part, it says, suppose ED is 16 centimeters. So that means that measure right here is 16 centimeters. And then DA is 20 centimeters. So DA is 20, so I'm going to fill in stuff on my diagram. And then it wants us to find DC. So I need to figure out the measure of DC. So DC is going to be this segment right here. Now, knowing that BD is the perpendicular bisector of AC, that means I know DC is the same measure as dA. And I know this because D is the same distance from C as it is from A. So if AD is 20, that means CD is also 20. So my answer for the value or length of DC is 20 centimeters. And that is your answer for that part. All right, for the next part of this question, it says, suppose EC is 15 centimeters. So we're saying EC is 15, so this segment here is 15 centimeters. And BA is 25. So BA is going to be this. So they're saying 25. He wants to know the length of BC, and BC is that measure right there. Again, if BD is the perpendicular bisector of AC, if I know that AB is 25, I know that BC is also 25. And I know that because B is the same distance from A as it is from C. So that means BC is 25 centimeters as well. So that is using the perpendicular bisector theorem to go through and find segment lengths. Now, parts B and C carry over the same idea as what we just did in A. Now, I'm not going to do both of these. I will leave C for you to go through and do, but I do want to take a look at B. So if you take a look at B, it says WY is the perpendicular bisector of AB. So WY crosses at 90 degrees and it cuts this in half. So it means AX is the same measure as BX. And then if I know that that is the perpendicular bisector as they've told me, I also know that W is the same distance to A as it is to B. So that means AW and BW are the same measure. So using all of that for what I just said, I know that AW is 27 because BW is 27, and I know AX is 18 because BX is also 18. All right, so knowing all that, I can go through and answer for the different segment lengths. They want to know what WA is. Well, WA is this segment here. And we've already stated that that is 27 units. Then for AX, that is this segment right here. And we already stated that that is 18. And then the last one they want me to find is AB. Well, AB is this entire thing. So that's AX plus BX, so 18 plus 18, which is 36. So I just took AX, which is 18, plus BX, which is 18, which got me 36. All right, so that is how you use the perpendicular bisector theorem to find different segment lengths. Like I said, I'm going to leave part C for you to do, to give you a little practice and see how you feel with this. It is done in my completed notes, so you can always take a look there to see how you did on that. All right, now, with the perpendicular bisector theorem, there is also the converse of the perpendicular bisector theorem, which states if a point is equidistant from the endpoints of the segment, then it lies on the perpendicular bisector. So how we are going to use that is we're going to use the converse of the perpendicular bisector theorem and the Pythagorean theorem to help us go through and solve stuff. All right, so I just mentioned the Pythagorean theorem. Let's recall what the Pythagorean theorem is, because it's something you should have hopefully have learned before, but in case you do not recall, let's talk about it now. if I have a right triangle, okay, a right triangle means that one of my angles is 90 degrees, as indicated here. The two smaller sides that touch the right angle, so sides A and B, are considered my smaller sides, and they're the ones that form the right angle. So the two sides that form the right angle are considered my A and my B. The side opposite my right angle is considered my C. Now, Pythagorean Theorem states that for a right triangle with legs of length A and B and a hypotenuse of length C, a squared plus b squared equals c squared. So we're going to use this a squared plus b squared equals c squared to help us go through and solve for example 2. So example 2 states, use the converse of the perpendicular bisector theorem and the Pythagorean theorem to solve. So for A, it states that AD is 10 inches long. So I know AD is 10 inches long. They also tell me that BD is 6 inches long, and they want me to find the length of AC. So I need to figure out how long AC is. Now, on the other side, in example 1, to figure out AC, we would have taken AB and CB. We would have added these two measures together to figure out the whole thing of AC. Now, we don't currently know what AB or BC is, so we can't do that. So we need to figure out what it is. So we're going to use the Pythagorean theorem. And to use the Pythagorean theorem, remember the two sides that form my right angle are considered my A and my B, and the side opposite is my hypotenuse, so this is going to be C. So the Pythagorean theorem states a squared plus b squared equals c squared. So my a squared, I don't know what it is, so we're just going to call this a squared, plus b squared, which is 6, so 6 to the power of 2, equals c squared, which is 10, right there. So I now have a squared plus 6 squared plus 10 squared. I have to go through and solve for a. Now, the thing you need to know is we're going to go through and apply all the squares. I cannot do a to the power of 2 and get a number, but I can do 6 to the power of 2 and 10 to the power of 2. So if I go through and do that, if I did 6 to the power of 2, we get 36. So this is a squared plus 36 equals 10 to the power of 2 is 100. So I have a squared plus 36 equals 100. We need to subtract the 36 to the other side. So we're going to do 100 minus 36. So we get a squared equals 64. Now, the part that you may not remember from before, or if this is completely new to you, to get a alone, because this is a to the power of 2, I need to have it as just a. To get rid of that power of 2, we're going to take the square root of both sides. The square root of both sides cancels out the square root in the 2, so we just get a equals. If I take the square root of 64 to do the square root on a TI-30, we're going to hit second and then x to the power of 2. The reason I hit second is because if you see the x to the power of 2, above it is the square root symbol, and it's yellow, so I need to hit yellow or the second, and then x to the power of 2. So we have 64, so we're going to take the square root of 64, and we get 8 for the value of a. So that means this segment right here is 8. So if I know this is 8, that means I also know that this right here is 8. So if I want to know the entire thing of AC, it's going to be 8 plus 8. So AC is 16 inches long. And that is how we're going to use the perpendicular bisector theorem and the Pythagorean theorem to solve for measures. Now, it might be helpful for me to go through and do another one, so I am going to talk about part B, just that way we have a little more exposure to this. So, let me move this on up. Alright, part B states, given PA is equal to PC and BA is equal to BC, use the diagram to find the lengths or angle measures described. So what they're saying is that PA and PC are the same measure, and that BA and BC are the same measure as well. So BA and BC are the same measure. So I know that this is equal to this, and this is equal to this. Now, in the question, they tell us that PA is 13, and that PB is 5. So PB is going to be this right here. And what they want us to figure out is what the length of AC is. So we're going to go through and figure out what the whole length of this whole part is. So we're going to do like we just did for part A, where we're going to use the Pythagorean theorem to go through and figure out what AB equals, and then we're just going to double it to figure out AC. So we need to set up our Pythagorean theorem again, and like last time, I'm going to consider, this time let's figure this as x. It might be easier to follow. So I don't know what this segment of AB is, so we're going to call that x. This is my A, this is my B, and this is my C. So if I go through and write the Pythagorean theorem, it would be x squared plus 5 squared equals 13 squared. So the two sides that make a right angle, so that would be AB and PB, so x and 5 are my A and B. My hypotenuse is on the opposite side, so 13. Alright, so now we just go through and solve. 5 to the power of 2 is going to be 25. So we have x squared plus 25 equals 13 to the power of 2 is 169. We subtract the 25 to the right, so we get x squared equals 169 minus 25 is 144. Then we take the square root of both sides, so it cancels on the left. We're left with x. The square root of 144 is going to be 12. So x equals 12. So that means I know that AB is 12. If I know AB is 12, that means I know BC is also 12. And it wants me to figure out what AC equals. So the whole thing for AC is 24 units long. And that is our answer for that one. Now, sometimes they may just ask for AB or AC or BC. So you may not have to do the entire, add them together. You may be fine with just that. Okay, so that is using the Pythagorean theorem with the perpendicular bisector to go through. I highly suggest you use this as a reference. If you need help setting up the Pythagorean theorem, what numbers go where, and how to solve it, please let me know. via email or next time you see me. I will be glad to help you walk through it. Expect one of these to appear on your quiz, and just be ready for that. Now, 99% of what you're doing is the other stuff. It's just simple seeing the stuff and then finding its matching part. There is occasionally a problem or two that's going to have you use the Pythagorean Theorem. Okay, so the last thing to talk about is example 3. So let me go ahead and move this up. Now, example 3 states, find the measure of the angles in the diagrams below. So we are given a diagram here. We have angles X, Y, Z, W, V, and then I'm given a right angle box here. So that means that I do know that this is 90 degrees. Okay, so before we start going through and filling stuff in, it changes situations after here and here. So we're not going to run through and find every single part right now. But for this first one, it wants to know the value of Z. So we're talking about this angle right here. Well, if we look at Z, okay, the only other thing I know about angle measures here is this angle here, which is 90. What two angles are these? You have to think back to 4.1. In 4.1, we talked about vertical angles. Vertical angles are angles that are opposite of each other. So other vertical angles would be Y and V, X and W. So Z and 90 are vertical angles. So that means Z is also 90 degrees. Alright, so if we look at this part, so it states if y is 50, what is the value of x? So if y is 50, what is the value of x? So if this is 50 degrees, what is the measure of x? Well, if we first of all just kind of ignore the bottom part, okay, this forms a straight line, all three of these, so that means they add up to be 180. Or the other fact I could know is if this is 90, that means this is 90 as well. So these two angles are complementary, which means they add up to be 90 degrees. So 50 plus what equals 90? Well, 50 plus 40 equals 90, so that means x is 40 degrees. We can get that from doing 90 minus 50 to get 40. Alright, for the third part, it states if V is 60, so if this is 60 degrees, what is the value of W? So again, if I ignore everything else here, okay, these two are complementary, they form a right angle, so it means that they add up to be 90 degrees. So 60 plus what equals 90? In this case, it's going to be 30, because 30 plus 60 is 90. We can also find that by doing 90 minus 60. Okay, so that is example 3, part A. Now, I want to take a look at part B, and I'm actually going to cover up part A, and we're just going to take a look at B, so that way we're not distracted. Alright, so for part B, it says that B is parallel to D, and C is parallel to E. So B and D are parallel, and C and E are parallel. States that the measure of angle 1 is 50 degrees. So angle 1 is 50 degrees. And the measure of angle 5 is 90 degrees. Now, this wants us to go through and find the measure of the angles below. So what I'm going to do is actually write angle 1, angle 2, 3, 4, 5, and then 6. So they have 6 angles they want me to figure out. Well, we were already told that angle 1 is 50 degrees, and that angle 5 is 90 degrees. All right, so we need to go through and figure out what the measures of angle 2, 3, 4, and 6 are. Now, there's a variety of ways that we can do this. And we're going to use vertical angles, supplementary, complementary, corresponding angles, same side interior, alternate exterior, and same or alternate interior as well. Now, if we wanted to go through and find the measure for angle 2, okay, if we look at these two lines here, okay, if I were to focus on this angle and this angle, okay, if you were to rotate it a little bit, what type of angle relationship do those two appear to be? And we're thinking alternate interior, same side interior, corresponding, or alternate exterior. These two are corresponding angles because they're on the same side of the transversal, on the same side of the parallel lines. Remember, corresponding means that they are the same measure. So that means I know that angle 2 is 50 degrees as well. All right, next for angle 3. For angle 3, okay, I have 90 next to it, but that doesn't really help me with anything. But I do have this angle 2 that's opposite of it. Remember, opposite angles are vertical angles. And vertical angles, like 2 and 3, are congruent to each other. So that means angle 3 is also 50 degrees. Now, if we were to focus on angle 4, so angle 4 here, okay, if we looked at vertical, well, 4 and 6 are vertical, so we'll keep that in mind. I don't know anything about either one yet, so let's figure out something about 4 or 6, and let's take a look at 6. So if I were to cover up this top half, and we just focus on this, 4, 3, and 5 form a straight line. Because they form a straight line, that means that they add up to be 180 degrees. So that means 90 plus 50 plus whatever this is should equal 180. Now, because I know this is 90, that means I know this part is 90 degrees as well. So that means angles 4 and 3 are complementary, which means they add up to be 90. So what plus 50 equals 90? If I do 40 plus 50, I get 90. So that means angle 4 is 40 degrees. Because I know angle 4 is 40 degrees, 4 and 6 are vertical angles. That means they're congruent, they're opposite of each other. So that means 6 is also 40 degrees. All right, so that is it for example 3, and that is also it for our notes on section 4.4, dealing with perpendicular lines, the perpendicular bisector theorem, and the Pythagorean theorem. So that is it for our video and our lesson today. If you have any questions, as always, just let me know next time you see me or shoot me an email. Otherwise, that is it for today. Thank you for listening, and have a great day. All right, bye.